We'll now continue our discussion on section 2.2. We'll look at a definition for the x and y intercepts. Given a graph in the Cartesian plane, any point where the graph intersects the x-axis is called an x-intercept, and any point where the graph intersects the y-axis is called a y-intercept. So in other words, the x-intercept is the point where the graph crosses the x-axis. And likewise, the y-intercept is the point where the graph crosses the y-axis. Furthermore, our definition says, all x-intercepts are of the form C0 and all y-intercepts are of the form 0C. More importantly, what this says is that if you have an x-intercept, then the y value is 0. And if you have a y-intercept, the x value is 0. And that is going to help us as we solve our problems. So let's begin with an example. Find the x and y intercepts of the following equations and then graph each equation. So we begin with 3x minus 4y is equal to 12. If we want to find the x-intercept, then we're going to remind ourselves that the y value is 0. So what we can do is we can take our equation, 3x minus 4y is equal to 12, and we can plug a 0 in for the y. So that gives us 3x. The 4 times 0 cancels into 0 is equal to 12. And dividing both sides by 3 tells us that the x will equal 4. So our x-intercept is going to be the point that has an x value of 4 and a y value of 0. Now our y-intercept, we're going to do something very similar. We're going to this time say to ourselves that we know that the x is equal to 0. And we're going to take our equation. We're going to plug a 0 in for the x, which will cause our first term to fall out, leaving me negative 4y is equal to 12. We'll divide both sides by negative 4, and y is equal to negative 3. And so we now know that the y-intercept is going to have an x value of 0 and a y value of negative 3. Now it asks us to graph this equation, and so we're going to go to a graph and we're going to plot these 2 points, the 4, 0 and the 0, negative 3, and connect them, because we know that on a linear equation it's going to graph a line. So you can see that here. We have plotted the point 0, negative 3. We have plotted the point 4, 0, and we connect them for our graph. Part B of the example gives us a second linear equation and asks us again to find the x and y intercepts and then graph it. Now before I start to find the intercepts, I want to simplify this a little bit. I'm going to distribute this negative through the parentheses. So my original problem is 4x minus, and in parentheses we have 3 minus x, and then we have plus 2y is equal to 7. So we are going to distribute that negative through that parenthesis, giving me 4x minus 3 plus x plus 2y is equal to 7. We'll combine the 4x and the x, making 5x. We'll keep the 2y. And then we have a minus 3 is equal to 7. I'm going to add 3 to both sides, getting it into standard form. 5x plus 2y is equal to 10. And now we're ready to solve for our intercepts. So for our x-intercept, again, remember that we know that the y is equal to 0. So we can take our equation and plug a 0 in for the y, which would cause the second term to fall out. We have 5x is equal to 10, so x would have to equal 2. So our x-intercept would have an x value of 2 and a y value of 0. And then we'll do the same thing for the y-intercept. This time we know that the x is equal to 0. So we'll take our equation, we'll take our equation and we'll put a 0 in for the x, which will leave us 2y is equal to 10, so y is equal to 5. And so our intercept has an x value of 0 and a y value of 5. And again, to plot this equation, we're going to plot these 2 points and connect them with a straight line. So you can see that that's done here. We have the point 20 plotted, we have the point 05 plotted, and we have connected to draw our equation. We're now going to look at a special case for graphing lines, specifically those that are either horizontal or vertical. Equations of horizontal or vertical lines are missing one of the 2 variables. They're either missing the x or they're missing the y. An equation that has only an x, for example, and I'm just going to say x is equal to a number, so that could be x is equal to 3 or x is equal to 4. This is going to graph a vertical line. And if the equation only has a y in it, so y is equal to a number, like y is equal to 5 or y is equal to 7, that's going to graph a horizontal line. And as I said, these are special cases because they don't have both variables. So let's begin with this first example, which says 5x is equal to 0. We can see right off that we only have an x, so we know that it's going to graph a vertical line. I want to simplify it so it's of the form x is equal to a number. So I'm going to divide both sides by 5. And so 0 divided by 5 is 0. And so our equation is x is equal to 0. So this should be a vertical line at x is equal to 0. So let's go ahead and graph this one. If you look at your x-axis, right here is where we have 0. And we're going to draw a vertical line through that point. So this is the graph of the line x is equal to 0. Okay, part B, we have 2x minus 2 is equal to 3. And again, I only see an x value, so I know that it's going to be a vertical line. Let's look at what vertical line. I'm going to solve this equation for x. So my equation is 2x minus 2 is equal to 3. I'm going to begin by adding 2 to both sides. So that will give me 2x is equal to 5. I'll then divide both sides by 2, which gives me an equation x is equal to 5/2. So again, here is your x-axis. 5/2 is 2.5. So you can find that point on the x-axis, which is sitting right about here, and draw a vertical line. And our last example, 3x plus 2 times the quantity x plus 7 minus 2y is equal to 5x. And at first glance on this equation, I don't necessarily think it's a horizontal or a vertical line because I see both variables. But when I go to try to put it into standard form, we're going to see that one of those two variables will disappear. So let's begin by taking this 2 and distributing it through the parenthesis. So that's going to give me 3x plus 2x plus 14 minus 2y is equal to 5x. And then we're going to combine the x's, so 3x plus 2x is going to give me 5x plus 14 minus 2y is equal to 5x. When we subtract the 5x from both sides, we see that it falls out completely, leaving me 14 minus 2y is equal to 0. Solving for y, I'm going to subtract 14 from both sides. So negative 2y is equal to negative 14. And then as a final step, divide by negative 2. So we have y is equal to 7. Remember that if it only has a y, it is a horizontal line. And so you can see that here is the 7 on the y-axis, and we're drawing a horizontal line here.